Alright, so this video talks a lot about different parts of a circle and the different types of angles we get in those various parts of a circle. So the first part is just several definitions, and I have this picture here to kind of give you a visual representation of those definitions. So I'm just going to go through them one at a time. So the diameter is just the line from one side of the circle to the other that goes through the center. So this red line right here, it goes from one end to the other, but it goes through the center of the circle. The radius is a line from the center of the circle to the outside of the circle. So it's not actually labeled on here, but it's just from the center to the outside. That would be considered a radius. And anywhere on the circle you drew it, it's still a radius. It's going to be the same length every time. And it's half of the diameter. A secant is a line that goes through a circle intersecting at 2 points. So if we see this line right here, it goes through the circle, but it intersects on one side and the other side of the circle. It intersects the circle twice. A chord is a line from a point on the edge of the circle to another point on the edge of the circle. So if you started at one edge of the circle, and you can end wherever you want on another side. So if I started here and ended over here, that would be a chord. If I started here and ended here, that would be a chord. So a diameter is technically also considered a chord because it goes from one end of the circle to the other end of another point on the circle, and it's the longest chord. Because it goes through the center, it's able to have the longest length. The next one is a tangent. So a tangent is a line that intersects a circle only once on the edge of the circle. So where a secant goes through the circle and intersects twice, a tangent line goes through the edge of the circle, but it only intersects once. So if we come look right here, this pink point is the only point this blue tangent line intersects with the circle, which leads us to the point of tangency, which is just the point where that tangent line intersects the circle. So this pink point where the circle and the tangent line intersect is called a point of tangency. So those are kind of a lot of definitions, but it helps us to understand the structure of the various things that we're going to be talking about. Note that circles are congruent if they have the same radius. If you think about it, the area and circumference of a circle, so the formulas for those, circumference is 2 pi r, and area is pi r squared. So the pi and the squared is going to be the same, and the 2 pi is going to be the same. The only thing that can vary in the circle is the radius. So if the radius is the same on two circles, then the circumference is going to be the same, and the area is going to be the same. Thus, the circles are going to be the same. So if you think back to when you've learned about dilations of other shapes, we have talked about how a dilation of a triangle, it makes the two triangles similar. So if we can take the, the side lengths of one triangle and multiply them all by 2, then we have a bigger dilation of that triangle, and those two triangles are considered similar. So if we think about that with circles, if the only thing that can change is the radius, then two circles are always going to be similar because you just multiply that radius by 2 pi because they're all relative to each other through pi, then every circle is similar to every other circle. So that's kind of an interesting fact. I'm going to go ahead and now label some specific angles in a circle. So if we check out this circle, our blue angle, and I'll go ahead and write it in blue. So angle A, oh, that's not blue. Angle AOC, this blue angle, this is what's called our central angle. So this right here, central angle. An interesting thing about the central angle is it's equal to its arc measure. So if we measure our arc measure in degrees instead of in arc length, if this central angle was 60 degrees, then from A to C, that arc angle would also be 60 degrees. And then our red angle that we have here angle ABC, is what's called an inscribed angle. And I'll give you some interesting info on that in just a minute. And then one angle I'm actually going to have to draw on here is if I have a tangent line through this point, tangent line through this point, this purple angle right here, and I'll label this D. So angle ADC is what's called a circumscribed angle. So these are the three main types of angles we're going to talk about. So the central angle goes through that center point. An inscribed angle is from one edge of the circle to the other, and then a circumscribed angle is actually on the outside of the circle made by two tangent lines. So there's lots of interesting things about these different types of angles, which I'll scroll down and show you a little bit. We have three different theorems. So the central angle theorem, the inscribed angle theorem, and the circumscribed angle theorem. So the central angle theorem is that the central angle is always twice the measure of the inscribed angle. So we're going to say that the inscribed angle is 20 degrees. Well, then the central angle that comes from those same 2 points is twice that. So this would be 40 degrees. The inscribed angle theorem is very much the same as the central angle theorem. It's just in relationship to, the relationship is switched. So the inscribed angle is always half the, and we're missing a word here, central angle. So if I didn't know that this was 20, but I knew the central angle was 40, I know the inscribed angle is 20. And then let me go ahead and draw our other angle again. So this angle here, the circumscribed angle, is equal to 180 degrees minus the measure of the central angle. So where the central angle is 40 degrees, if I do 180 minus 40, this angle is 140 degrees. So using those three theorems, we can find a lot of missing angles when we're looking at a circle. So we're going to go ahead and do some examples of that. So we're using our knowledge of central angle and inscribed angle theorem to find our value of x. So if we look here, this arc measure is 124 degrees, and I'm going to go ahead and just draw our central angle so you can get an idea of what's happening. And remember that this arc length and the central angle are the same, so this is also 124 degrees. Well, the inscribed angle is half of that, so half of 124 degrees is 62 degrees. On number 2, this arc measure is 167, and then this central measure would also have to be 167 because those are the same. So this is 167 degrees. And then number 3 is that same idea, except it gives us the central angle and is looking for the arc measure. So the arc measure is also 139 degrees. And then on number 4, we have an inscribed angle of 96. So what is the arc measure or the central angle? Because those would be the same. So that's double 96. So if I double 96, I have 192 degrees. So those are just a few examples of what we can use those theorems to help us find those missing angles. Using your knowledge of the central angle and inscribed angle theorem, we're going to keep finding the values for x. So this one seems a little bit tricky because it doesn't give us the angle measure. But if we look, this is a straight line, right? So its angle measure is 180 degrees. So the inscribed angle has to be half of that, which is 90 degrees. So I know that 4x plus 10 is equal to 90. So if I can just solve this for x. So I'm going to minus 10 on both sides. 4x equals 80 divided by 4 on both sides. And x equals 20. And then if I look at this one's interesting. So this line goes from this point to this point is this angle. And this angle is this point to this point. So notice they come from the same 2 points, so these two inscribed angles have to be equal to each other. So 2x plus 60 has to be equal to 4x plus 12. So I'm going to go ahead and minus 2x from both sides, and then minus 12 from both sides. And 60 minus 12 is 48, which is equal to 4x minus 2x, which is 2x. If I divide by 2 on both sides, x is equal to 24. All right, and then over here, I have one of my angles is an inscribed angle of x plus 4, and then the arc or the central angle is 6x minus 100. So I know that if I multiply this by 2, it's going to be equal to this, so I can actually write it just like that. 2 times x plus 4 equals 6x minus 100. So if I multiply this, 2 times x is 2x, 2 times 4 is 8, equals 6x minus 100. So I'm going to add 100 to both sides, subtract 2x from both sides, and I get 108 is equal to 6x minus 2x, which is 4x. So I'm going to go ahead and divide by 4, and 108 divided by 4 is 27, so x equals 27. So there's a couple more examples of how we can use these theorems. One theorem we haven't done any example problems with yet is from circumscribed angles. So we're going to go ahead and look at some circumscribed angles. So I have this angle is equal to 134 degrees. I want to know what my circumscribed angle is. Well, I know they add up to 180, so I can just do 180 minus 134, which is 46 degrees. And then, well, I know this angle, but I don't know this one. Well, again, they still add up to 180, so it doesn't matter which order we look at. I can still do 180 minus 36, and I know that this is 144 degrees. And the same idea with this last one to find that question mark angle. 180 minus 49 is equal to 131 degrees.